This is brought to you by the Alumni Association of PISJ-ES.
Hey guys, in this lecture we'll be talking more about some gradient problems here. Okay, so we know what gradient is from the earlier video. Gradient is simply change in y, change in the height. For example, if this is the vertical height, change in vertical height. So, for example, if this is the y2, the value of y here, and the value of y here, so this is simply y2 minus y1 divided by the corresponding, for example, if this is the line, so the corresponding change in x, which is x2 minus x1. So it is basically the change in height over change in length. Let's see some more gradient problems here. So let me do an example here again, so that you guys are practiced enough before we move on. So this is the line, this is the axis. Okay, this is a graph. Here. Since I can't see anything on this tablet, so it's a little difficult for me to make out where the pen is actually. So this is your graph. Okay, for example, this is again a distance time graph. Here is a meter and here is a second. Now I have a line here, something like this. This is a straight line. Just imagine this is a straight line. Okay, this coordinate of the line is 0 and 0 because it's a 0 on the x-axis and a 0 on the y-axis. For example, this coordinate here is a 4 and a 4. 4 on the x-axis and 4 on the y-axis. So the two coordinates that we have is 0, 0, 4 and 4. Now first you have to decide which one is the point 1 and which one is the point 2. So I'm taking this one as point 1 and this one is point 2. Okay, it's always better to, if you have a choice, it's always better to choose the greater one as point 2, since you will be subtracting point 1 from point 2. So the answer won't be negative. You won't get confused. So that is the strategy here. Not really a strategy. It doesn't work all the time. So we'll see when it's not working. So here, y2, this is the y2 and this is the y1. 4 y2 minus y1 minus 0 divided by x2 minus x1. 4 minus 0. So the gradient is 4 minus 0, 4 over 4. 4 over 4 is 1. The gradient is 1. Let's take another example. It's a very simple concept. Let's take another example here. And let's just take a graph here. I'm getting used to the scale, I guess. So this is the graph again. Now let's see. It's not starting from the origin, it's starting from a point 1, and this is, let's say, point 5. This is the mark, the fifth mark. Okay, so the line starts from here and goes to here. This is the first mark, this is the 0 on the x-axis. Again, this is a meters and seconds, the same. So this is 0 here, and let's imagine this is 4. Okay, just for the sake of it, it's a random thing. So this point, as in this thing, comes out to be 4 on the x-axis. So this point, let's talk about this point first. This point is 0 on the x-axis and 1 on the y-axis. So this is what it is, 0 and 1. It's a little retarded here, not retarded actually, but this is a 0 and a 1. This point here is 4 on the x-axis and a 5 on the y-axis. So it's basically 4, 5. So now if you take the gradient, which is y2 minus y1, y2 minus y1, 5 minus 1, divided by x2 minus x1, 4 minus 0. This will give you 4 over 4, which again is 1. Now if I choose any point here, for example, let's see this point. It's not a proper graph, so I'll just be choosing a random point here. Let's say this is 2, and here this is 3, approximately 3. Okay, this is just a random figure. Let's say this point. Find the gradient at this point. This is what I'm asking you. Find the gradient at this point. Now let's see, we are finding another gradient. Let's write the coordinates down here of this. We are taking this 1 point. This is the first point, 0 and 1, and this is the second point, 2 on the x-axis and 3 on the y-axis. Using this point now. Okay, first we were using this point, and now we are using this point. Let's see. The strategy says if you have a choice, take the greater one as the point number 2. So this becomes our point number 2, and this becomes our point number 1. Now, y2 minus y1 over x2 minus x1, 2 minus 0. This becomes 2 over 2 is equal to 1 again. So this shows that whichever point you may choose, the answer, the gradient remains the same. The gradient remains the same for a straight line. It never changes. For a straight line throughout, you can take any 2 points on the line. I can take this point randomly and this point randomly. The gradient will always be 1. That is the characteristic of a straight line. That's what I told you in the previous video. But for a linear curve, the gradient remains constant. So whichever line you may choose, this would give you a constant gradient on a straight line.